I think it's kombucha, Kevin. Chahomba. I like that. They should have called it Chahomba. That sounds better.
What is it?
Kombucha. Chahomba.
Chahomba. I'll take 2 Chahombas.
All right. Let's get to this stuff. So today we're going to be going over 4.6 and 4.7. This is more fun stuff with polynomials. 4.6, we're just going to go over the basic operations with polynomials in several variables. And so it's polynomials that instead of just like an x squared, it might be an x squared times y or something like that. We'll go over how to add, subtract, multiply those. It's really pretty basic. You guys should sort of, I mean, it's more or less just how you multiply regular polynomials. You just have to take into account the extra variables when you're doing your multiplications. So in this chapter, we're going to go over how to evaluate these polynomials with several variables, what it means to be a like term, how you pick out a degree, addition and subtraction, and multiplication of multivariate polynomials. All right, so how do we evaluate a polynomial with 2 variables? Well, we've already done this in a couple of examples in the past. One of them was even on the last test. When something has 2 variables and they ask you to evaluate, you just plug in the values for both those variables where appropriate and calculate. All right, and so this one, I'm just going to go from left to right and fill in the x and the y where it goes in. So 4 plus 3 times x, which is -2, plus x, which is -2, times y squared, which is 5, plus 8 times a -2 cubed. Notice I'm putting in these parentheses around the negative. That's really important so you remember the negative gets squared too, or cubed. And then for the y,
The negative gets squared?
yeah, and so remember how this is different than this, right? This is equal to -4. This one is equal to +4. Because in this upper one, the negative isn't squared. What this is really saying, -2 squared is really -1 times 2 squared. Okay, so unless you have the parentheses, then that square doesn't apply to the negative. When it's like this, in this example up here, then the square distributes to the -1 and to the 2, and so it's all squared. Okay, so let me erase all that junk. All right, so I guess we'll just go through this step by step so we don't get too jumbled up here. So we have a 4 still. That is 3 times -2, that's a -6. Right here, we have a -2 times 25, that's -50. And then this final one, what do we have here? Might have to break this one down. So we have 8 times 2 cubed. What's 2 cubed? Good, good. -8 is -2 cubed. 5 cubed is 125? 125. All right, so, so if I sum all these guys up, I get a -52. What happens when I multiply all this out? Anybody got their calculator? What is it? 8,000? Is that really what it is? 8,000. 52 minus 8,000. Well, that is 8,000 -52. All right. So that's basically it. You make sure that you sub in the values they give you for where they go, and you make sure that the parentheses get kept around your negatives always. All right. So that's how we evaluate those. For an example here, suppose we're given this equation for the surface area of a right circular cylinder. This is the equation for that. And what it means by a right circular cylinder is like a pop can, where this is like the height, and let's see now, and then of course this is the radius. So they're asking us to evaluate this. They're saying, let's see now, they're saying what's the surface area of one of these 12-ounce cans with a height of 4.7 and a radius of 1.2. Well, to figure that out, we just plug it all in there. So we have 2 pi times r, which was 1.2, and that is times h, which was 4.7. Then we add that to 2 pi times the radius squared. So that would be 1.2 squared. All right, so I'm definitely going to need my calculator for this one. So 2 times, where's my pi at? There it is. 2 times, do you guys have pi on your calculators? If you don't know, get them out and locate it right now. If you don't have pi in the test, this one could throw you for a loop. Yeah, I would accept that. If you didn't have a calculator and you left it uncalculated because you couldn't calculate pi, that would be okay. Because, yeah, you can't really calculate pi by hand very well.
I don't see pi.
No pi on yours? Get a new calculator.
Right there.
Yeah, it's on the right side.
But how do you make it?
But
The second button on the left. On the left side, the second, the orange button.
all right.
It's color coordinated.
Yes.
Thanks. Yeah, I got you.
All right. Did anybody else do that calculation? Am I correct? It could totally be wrong. That was an ugly
I think
one.
it's wrong.
It's wrong. That's right.
That's right.
All right, good. Yeah, I'll trust you over Kevin. So, all right.
Don't put me up front.
Front Street. I love that. I love that term. All right. So that's it, right? If they ask you to evaluate something, or even the word evaluate's not even in here, if they give you a formula and then they give you values for that, plug them in and calculate.
We just want to see that we put the formula out there.
This would be your intermediate step if you're on an exam, right? Don't just plug the formula into your calculator and then give me 44.8 with no work on the page. There's nothing I can do with that. Give me this intermediate step where I plug everything in, and then you can do the rest on your calculator. That's fine. I just need to know that you know that one step. All right. Like terms and degree. So remember, the degree of a monomial is the number of variable factors in that term. Identify the degree of each term and the degree of the entire polynomial. All right, so with this first term, 9 times x squared times y cubed, we have 2 factors of x, 3 factors of y. That makes this a degree 5 monomial. Does that make sense? And so you count all factors, even if they're different. So for this next one, negative 14 xy squared times z cubed, there are 2 for the y, 1 for the z, and 1 little guy up here for the x, so this is a degree 6. X times y, that's a degree 2. There's only 2 variable factors. 1, exactly. What about 5 squared, 5x squared? 2.
2.
This guy here?
1.
0. Right? Yeah, remember, it's the number of variable factors. So if there's no variable factors, it's 0. So now the other part of the problem asked us, what's the degree of the entire polynomial? That's the degree of the highest degree term. And in this case, that was 6. If they asked us what the leading coefficient was, that would be negative 14.
They asked what?
What the leading coefficient is. And so the leading coefficient is the coefficient on the degree of the highest term. All right, so when they ask us to combine like terms, just like before, we just got to make sure it's the exact same terms, right? And so 9x squared y We can't combine that with 3xy squared because it's not the exact same variable factors.
5x squared y.
Yeah, we could add this one and this one though, because both of these have 2 factors of x and 1 factor of y. So 9 minus 5 is 4x squared y. And then we can also add these guys together because they have the same exact variable factors. So we have 3xy squared minus 1xy squared. That gives us a plus 2xy squared. Okay. Same works with this one, right? All we need to do is go through and pick out the terms that we like. So it also helps to do this by highest degree term first. You know, that helps you to organize, and it also puts it in the correct order right off the bat. Whether you use the 6a cubed or this is a 3rd degree term, the 6a cubed, but these are also 3 degree terms. So which one you use is up to you. I like to use the one with the single variable first and then move into doubles, but that's just my own preference. So I have 2 that are 3rd degree. That is 6 and a negative 11. So that is a negative 5a cubed. Those guys are gone. And then we have these 3rd degree terms as well. And so that's going to give us 3 minus 5. That's a negative 2ab squared. Now we have these 2 degree terms that are just AB. That's 9 plus 7, 16. And then we have just this one little single degree term left, plus B, and a 0 degree term, minus 1. All right, so that's it. I think we're probably going to go over how to check our work, but just like other polynomials, if you want to check your work on these, evaluate the first one for a couple of easy numbers. Try like 1 and 0 or something like that, or maybe 1 and negative 1, or 1 and 1, and then cross-check it with the answer for this one. If you're coming up with different answers when you input the same variables, something's wrong. That can save you a lot of points on a test for just that quick little operation. Yeah. All right. So again, when we add or subtract these guys that are multivariate, we just combine like terms, just like the ones that are not multivariate. So for this guy, we're going to do some more of this fun stuff. So I'm going to pick out the degree of highest term. First, I'm going to note there's a plus sign in the middle, so these parentheses don't really need to be there. They're not going to restrict us at all. We're just going to ignore them. If that was a minus sign, it'd be a different case. So first of all, pick out the 3rd degree terms. 8 minus 5 is 3x cubed. These guys are gone. Then I'm going to pick out the second, let's see now. Yeah, so I don't know, maybe I'm going to keep my x's together. I don't even know why. So we have one x squared term, so plus 4x squared. Now I'm going to move on to the y terms. So we have 2 2nd degree y terms plus 2y squared. And then we have just this solo y term hanging out. So that's it. Wait, what did I do wrong there? Nope, didn't do anything wrong. All right. So that's about it. Same thing works with these guys. Let's do another example. So once again, pick out a term that you want to go first. It should be one of the highest degree terms. We've got some 3rd degree terms, but we also have some 4th degree terms it looks like we can use. Yeah, so I'll pick out that guy to go first. Do we have any like terms?
No.
No, right? 5a3 is close, but it's missing the b. So this one just goes straight down. Goodbye. All right. Let's see now. How about this 3rd degree term? Do we have any like terms?
Yes.
Which one?
4a squared a squared b.
Excellent. So negative 4a squared b minus 2a squared b, negative 6a squared b. These guys go away. Okay. Let's see now. I don't know. Let's do this one next. You can see when we get on these multivariate examples, like the descending order means a little bit less, you know, because there's so many terms with like degree that are just in different variables. And so it's like, you know, there's really no clear path to which one I should choose next. I'll just choose whichever one I feel like choosing. So I'll choose this guy, and I'll see that we have a like term over here, 5 plus 3. Well, that's 8. Then I see that I have only one term, that's a cubed. So I'll just drop that down. Then I have 2 constant terms. Okay. All right. Since we haven't done enough of these already, so remember, with these ones, when we have this negative sign in the middle, we started off by switching the signs of each and every term that the negative is going to apply to, and then we just add them all together. So we have 4x squared y plus x cubed y squared plus 3x squared y squared plus 6y minus 4x squared y plus 6x cubed y squared minus x squared y squared plus 5y. It's almost impossible to keep the enthusiasm going on these problems. It's like it's impossible. You can't. Okay. All right. So let's see now. What's our highest degree term? 5. We got these guys, and then we got these guys. Are there any other terms like those?
3x squared, y squared.
Right, but those aren't the same, right?
Oh, no, they're not.
Are there any terms like these two?
No.
Nope, those are the only ones. So we have 7x cubed y squared. Cross those guys out. All right, the next one, maybe we'll do these guys next. What is? What's supposed to be a y cubed?
3x cubed y cubed is supposed to be 3x square y cubed.
Y cubed.
Oh, thanks, Ed. I was totally spacing out on that.
Which you notice.
Let's see now. Y squared.
I did notice.
Y cubed. Okay. Y cubed. All right. So those don't go together then, huh?
No.
No, that's too bad. I was happy about that, Ed. Thanks. All right. So this one's a 5th degree. It doesn't go with any other ones, so we're just going to add it on. 3x squared y cubed. Huh?
So if that one went first?
No, they're both 5th.
Okay.
Right? Yeah, each one of these 2 first terms is a 5th degree term. Okay, so let's look into the 4th degree term over here. There's no more like terms with that, so that one just comes straight down. X squared, y squared. I don't know why I'm doing this all in different ink. So now let's do some of the 3rd degree terms. These guys look alike. Are there any other like terms?
Those cancel out.
Hey, nice call. Boom, those cancel out.
Those cancel out.
What do?
Well, here we go.
So then we have the plain y's. 6 plus 5, that is 9y. That's it. As easy as that.
Can I ask, when you switch the positive and negative sign?
6 plus 5 is not 9. It's 11.
Oh, sorry. I'm sorry, LaShonda, what were you?
So at the beginning of, before you started adding the combining terms,
Yeah.
you're gonna, the negative in the middle stays negative as long as you switch out the other sign?
So the negative in the middle applies to this first term, and that's why it looks like it stays. It sort of does, if you look at it that way, but what it really does is apply to the 4x squared y, and so it shows back up down here in front of the 4x squared y. Like, you know, since these are all sums, it's totally appropriate if you wanted to rearrange everything afterwards, you know, and the negative just follows the coefficient that it's with. Okay?
So it applies to that first 4x.
Yeah, it'll apply to the first 4x squared y, and that's when I mean like you switch the sign of everything in there and add it together, right? All right. And 5 plus 6 is 11. No, I make those mistakes a lot. Okay, so when we want to do multiplication of polynomials, same thing that we do with single variable polynomials, right? We just do our FOIL. It's not really FOIL when there's 3 terms in one of these. All we do is multiply every term in one of the polynomials by each and every term in the other polynomial. To make things look a little simpler, I'm going to go ahead and choose this polynomial to draw my arrows from. Okay, so I'm going to multiply this by this, or actually maybe it's more like I'm choosing this one. That makes a little more sense. Okay, so I'm going to multiply 3x squared y by xy, and I'm going to get 3x cubed y squared. Then I'm going to multiply this same term by the second term in here. Okay, that's going to give us 6x squared y squared. All right, now I'm going to go ahead and do the same thing with this middle term. Oh, that's why I didn't want to do it this way, because this gets a little jumbled up, but that's okay, guys. Okay, so now I'm going to do it with this middle term. So now we're going to say negative 2xy times plain old xy. Okay, so that's going to give us a negative 2x squared y squared. We're going to do the same thing with the final term. That's going to give us a negative, oops, good, negative 4xy squared. Okay, so we've handled all the multiplications for these first 2 terms. Now we're going to do the 3y. So now we do the same thing. Multiply 3y by xy. So we get plus 3xy squared, and then 3y times the 2y, plus 6y squared. Now we go through and see if we can combine any like terms. Can we? Yeah, there's definitely some like terms in here, so let's go ahead and do that. So this first guy, this 5th degree term, that's the only 5th degree term. So that guy goes first. 3x cubed y squared. All right, so now we have some 4th degree terms, and they are like terms, so we can add them together. So 6 minus 2, that is positive 4. All right. That guy goes away, that guy goes away. Then we have these terms that have an x and a y squared included in them. Negative xy squared, right? Because there's a little 1 in here. And then we have this 6y squared that clearly doesn't add with anything. And that's it.
So that just represents an invisible one.
Yeah. And I don't know, these arrows, I remember now why I like to draw them from the other one, because this looks crazy, right? It's easier for me, yeah, it's easier for me if I draw the arrow from this guy, you know, and just say like, okay, 1 multiplication, 2 multiplication, 3, and then the same thing here. 1, whoops, do it with a different color. 1, 2, 3. That makes it a little bit easier to see when you've got them all. So you'll know that you've got all your terms. If you there's a little bit of combinatorics we can do here. If there are, so the number of terms that you should have in the end is the number of terms included in the first polynomial times the number of terms included in the second. So there's 2 terms in the second polynomial, there's 3 terms in the first, the total number of terms we had over here before combining them was 6.
You distribute it 6 times.
Yeah. And you know, like when you have two binomials and you're multiplying those, you should have 4 terms before you combine the like ones. If you're multiplying a polynomial with 3 terms by a polynomial with 4 terms, you're going to end up with 12 terms when you're done. So that's a good way to check to see whether you've done all your multiplications. Another way is to just draw your arrows. That's what I like to do. All right. And I mean, yeah, after you do enough of these arrows aren't necessary. You're going to pick it up, and it's just a mental thing you'll go through.
Now, if there was 3 on the left and 3 on the right.
Yeah. All right, so let's do some examples. So with these ones, we have P's and W's. I'm going to go ahead and FOIL this guy out. So this one's only 2 terms and 2 terms, so we can use our FOIL reminder. So the first multiplication is P times 2P. That's 2P squared. The O in the FOIL is going to be our outer. That's P times negative 3W. That's a negative 3WP. The I is going to be our inner term, and that's where we start our downward arcs. So that is going to be 5W times 2P. That's going to be plus a 10WP. And then we have the L, the last multiplication. 5W times negative 3W. There we go. Exactly. Now we can do a little bit of combining and then we'll be done, right? Notice we have 4 terms there, so that means we've got enough terms. So when we combine, we're going to get 2P squared plus 7WP minus 15W squared. All right. So, we can use a special product for this one, right? Special product says that a plus b squared is equal to a squared plus 2ab plus b squared. In this example, our a is equal to 3x and our b is equal to 2y. And so this guy, our result, just going to draw it down here, our result is 9. Well, actually, maybe we'll do this step at a time here. So our result is going to be 3x squared plus 2 times a, which is 3x, times b, which is 2y, plus b squared. So that's 2y in parentheses squared. Now we just do our simplification, right? The 3 is inside the parentheses, so we square it with the x, and we get 9x squared. With this guy, 2 times 3 is 6, times 2 is 12. And then we have an x times a y. And then for this, we're going to distribute this squared term, and so we square the 2 and the y, so we get plus 4y squared. And that's it. All right, so the other way to do this problem would be to write it out side by side and FOIL it. 3x plus 2y times 3x plus 2y. So if you're at a loss on the exam and you don't know any special formulas, it's totally fine to just brute force all this stuff. All right, so this guy here, we've got another example of where this special product is going to come in handy. As you can see with these kinds of terms, it might be a little messy if we wanted to multiply this out longhand ways, so we're going to use this special product once again. Except for stuff is a little bit different here. In this last one, we had a plus sign in the middle. So that changes the sign of this term in our special product. So now we're talking about, let me just partition us off here. Now we're talking about a minus b squared, and that's equal to a squared minus 2ab plus b squared.
So we're just tweaking the formula.
Yeah, exactly. It's just when there's a negative in here, there's a negative right there. That's the only difference. Okay, so capital A is equal to a cubed in this example, and capital B is equal to 7a squared b. Keep in mind, this negative does not come with the rest. It usually does when we're doing other things, but in a formula like this, the formula has the negative in the middle, and it doesn't have it included with the b. And so we don't take it with us. All right. So now we have our a and our b. Let's just go ahead and fill in this formula. So a squared, that is little a cubed squared. Then we have minus 2a, which is little a cubed. B, which is 7 little a squared b, plus b squared. All right, now we just got to do the math and simplify if we can. So what's the rule when we take an exponent to a power? Yeah, what is this? A cubed to the second power, what is that? Yeah, what do we do with these exponents? Do we multiply them or do we add them?
We add them.
Multiply them. This is one that you guys got to memorize, right? And, well, you don't have to because you can just write it on your note card.
Oh, we multiply.
Yeah, when you take a power to another power, then it's multiplication. When you multiply a power with another power, then it's addition. Okay, and you can do that in a test by writing this out the longhand way, right? A cubed squared, well, that's just a cubed times a cubed, and now we're okay to add them, and now we get a to the 6th. So this gives us a to the 6th on this first one. We have a 2 and a 7 in here. That's going to give us a negative 14. We have a squared times a cubed. That's going to give us an a to the 5th because we add those, and then we have a b left over. Now, we're going to distribute this 2 to each and every term in here. So we have 7 squared, which is 49. We have a squared squared, which is a to the 4th, because we're multiplying those, even though adding them would have worked. And then b to the 1st squared, that's just b squared. We can't really add any of those together, so we're done.
7a squared b, same principle applies with a cubed,
On this section?
Yeah.
Yes, yeah, it's the same thing I'm doing, yeah. Yeah, we're just distributing that 2 into each term, or the power into each term, and then applying it. All right. So, what do you guys think? Is there a special product that goes with this? You're like, I know, because you just asked, and you wouldn't ask if there wasn't one. Yeah, there is, right? And you might not see it right away because there's a bunch of crap right here. And the special product, yeah, it's a minus b times a plus b is equal to a squared minus b squared. Difference is squares. All right, so in this example, a is equal to 3x squared y. B is equal to 2y. So this guy is just going to be a squared, so 3x squared y squared minus b squared, 2y parentheses squared. Now we're just going to apply these, right? This 2, the squared gets distributed to each term. So we have 3 squared, which is 9, x squared squared, which is 4. Hold on, let me rewrite that. 4. And then we have y squared, which is y squared. All right, so now we subtract what we figure out this is. We distribute each in, and we get 2 squared, which is 4, and a y squared. We can't combine these, so nothing else to do. So once again, if you felt like doing this with the FOIL technique, you know, and drawing your arcs or, you know, doing your FOIL or whatever, that's totally fine. It might just save you a little bit of time using these special products.
Be on the same side as the
I don't know. It depends. It depends if you memorize the formula or if you know how to use the formula, you know. Some people might be completely uncomfortable using formulas and they feel safer doing everything the brute force method. There's a few different entities that I would do that with, if they'd have a simpler way that I didn't quite understand or I wasn't quite comfortable with, so I do it the brute force way every time. It worked. You know, it's not the best, but hey, if it works, that's what counts. All right, so with this guy here, this guy's tough to see at first. I even left myself a little note so I didn't miss it. There's a special product here, right? In order to, you see it?
Oh, I see it, but can't you just move it so you can use the product?
Yeah, exactly. You just switch your products around. Flip them.
Flip it.
Yeah, so because these are addition, right, these are commutative. You can swap them around and it'll be fine. So we're going to rewrite this as 5t minus 2x cubed y squared times 5t plus 2x cubed y squared. Yeah, and we're going to use the same difference of squares property that we used up here. So this tells us that we should have a squared minus b squared when we're done. That's our formula. All right. So our a is going to be 5t, and then our b is going to be a 2x cubed y squared. All right. So our answer, which is a squared, is 5t in parentheses squared minus what b is in parentheses squared, 2x cubed y squared, the whole thing squared. All right. The exponent distributes and we get 25t squared minus, this guy distributes as well, and we get 4. What's the exponent on this guy? 6, right? We multiply that 3 and the 2 because we're raising an exponent to another exponent. And y to the 4th, exactly. All right, oh, this is an interesting one. This is one that I usually don't see on my own. You know, they pointed it out in the book, so I can see it easily now. But on my own, I'd probably just go through and do this one brute force. Yeah, well, yeah, what you can see is that this sum, the 2x plus 3, we can count that as a single term. And so in a way, it's exactly saying a minus b, a plus b, where a is this whole sum, and b is just the 2y. All right, and so I'm going to write that down here. So a is going to be 2x plus 3, b is going to be 2y. All right, this guy is a squared minus b squared, and so this guy is going to end up as a squared, so that's 2x plus 3 in parentheses squared minus 2y squared. And so yeah, there's a little bit of extra legwork. We're going to have to FOIL this stuff out, but that's okay. Okay, so for this guy, when we FOIL it out, I don't know, we could use the special product, right? When you FOIL out squares, it should equal, actually, no, we're not going to use the special product on this one, just because they all use capital A's and B's, and I don't want to confuse it on this. So we're going to do this one the brute force method. Brute force. All right. I don't know why I just wrote a 3 there. So 2x plus 3 times 2x plus 3. We're going to get the result down here, and then we're going to go back to our original equation. Right? 4x squared for the first multiplication plus 6x. Then we're going to do our next set, 3 times 2x. That is another 6x. 3 times 3, that's a 9. Okay, so I'm going to go ahead and rewrite this whole equation down below. I'm going to replace this first sum with what I figured out right here, okay? So here we go. So now we're going to have 4x squared plus 12x plus 9 minus in parentheses 2y squared. That's a weird y. 2y squared. All right, so now to complete the problem, I just do that last multiplication. And that, when I distribute the 2 in there, I get 4y squared. And there we go. All right, so once again, keep your eyes open for special products. Sometimes they can appear in a little bit stranger forms than you're used to, like this last example. You know, without a doubt, I'll be working to, you know, make a few problems on the next exam simplified if you use special products. You know, I always try and do that just because, you know, there's got to be some benefit to knowing them, right? All right. Okay. Now let's go into division of polynomials. First, we're going to do a little bit of dividing by monomials. That's sort of like the easy example. And then we're going to go into dividing by polynomials. If you can remember how to do long division with just large numbers, you can probably figure out how to do this and remember pretty easily. It's very close to the same steps. So first we'll do monomials, which are not the same steps. So we're going to recall when we very first started talking about adding fractions, we said that if our denominator matches, we can combine those. Hey, Milvia, we can combine those to get to get one single fraction, right? So in this chapter, we're going to use that rule in reverse. We're going to take things that look like this, and we're going to split them up into 2 different fractions to make that division easier. So when I ask you to divide something like this, it's totally appropriate to just split it up into 3 separate fractions. So this splits up into x to the 4th over 3x plus 15x cubed over 3x minus 6x squared over 3x. So now I just go through and I cancel as appropriate. I have 1x here. So this will turn into a 3 because an x is going to cancel in the top and the bottom. I have a 15 over 3. That's just equal to 5. I have an x cubed over a single x. That's going to make this into an x squared. I have a 6 over 3. That equals 2. And I have an x squared over a single x. So just one out of each cancels there. Now let's go back and write down what we have left. So we have a 1/3 x to the 3rd. And then we have that added to a 5x squared minus 2x. Does that make sense to everybody? All the cancellations there and stuff? Okay.
Saves you having to write it out.
Yeah. Yeah, so just remember, when you have something that says divide and you only have a single term on the bottom, split them up. Yeah, it makes it so much easier.
You can divide separately.
Yeah. Yeah, and then it's just canceling. And you guys know how much I like canceling. It's so much fun. All right.
Divide and check.
Divide and check. So for this one, once again, we're going to split it up into 3 separate fractions. So our fractions are going to be 10a to the 5th, b to the 4th, over a negative 2a squared b minus 2a cubed b squared over, oops. So something to remember here, since this negative is attached to the lower part, that's going to come along with each one of our fractions. We can deal with it in the next step if we want to, but you want to leave it in there so that you know it's there. So negative 2a squared b.
You don't want to forget it.
You don't forget the negative. 6a squared b over a negative 2a squared b. Okay. Yeah, now we do a bunch of canceling, right? 10 over 2 in this first term. 10 over negative 2, that gives us a negative 5. A to the 5th over a squared. Remember when we have exponents over exponents, we subtract, right? So this is 5 minus 2a, which is a cubed.
Do they have to cancel or do we just divide straight?
It's the same thing. You mean,
2 and 10. 2 and 10.
yeah, it's basically canceling is the same as dividing. You are sort of dividing when you cancel. Divide, cancel. That's hilarious. Okay, so we have a b to the fourth and a b, just a plain old b in the denominator. So that's going to be b to the 4 minus 1, which is going to be b cubed. So right here, let's notice real quick that we have a double negative. So negative 2 over negative 2, that's a positive 1. So we're just going to write our plus sign in there. A to the third over a to the second, that's 3 minus 2, that's a to the 1. B to the second over b to the first, once again, that's just plain old b. So then we have 6 over negative 2, that gives us a negative 3. A squared over a squared, both those just cancel. B over b, that cancels, and we're done. Ta-da! There it is. Okay. So, now, recall our long division technique with respect to real numbers. So, remember how long division works? You guys should all be up on this because you needed to know it to test into this class. But basically, in your first place, right? I know, that's exactly what I said when they told me that. I tested into like 105 or something, and they're like, and you should know this and this and this. And I was like, dude, the test was multiple choice. I don't know any of this crap. All right, so back on focus. So in this first slot here, we want to write what we would multiply this guy by to get this. So that's a 1, right? 3 times 1 is 3.
Wow.
I know, this is monumental, but it's a good refresher. Just bear with me, okay? So, all right. So then we subtract this next line that we multiplied our divisor by our initial number or whatever. So when you subtract these guys, you get a 0, and your next digit drops down, and we repeat the process with this digit. Surprisingly enough, it's the same number. So once again, we multiply this by this, and then we subtract that from the next line. That gives us 0, and then our 9 drops down, and then we repeat the process one more time with this 9, and that's 3. And that's right. And then we say, okay, 3 times 3, well, that's 9. We subtract the 9, we get 0. There's nothing else to drop down, so we stop. All right, so with that in mind, let me show you how to divide these two polynomials. So for these guys, in this first slot, with this last example, we said, okay, what times this 3 is equal to this 3? And it's 1. For this, we say what times this first term is equal to this first term here. We don't worry about the 3 right now, okay? We just say what times this first term is equal to the term that's in question. Well, that's just x, right? So now we multiply x by x and x by 3. And so we say, now we have a negative down here, x squared, 3 times x is 3x. Okay, now we do our subtraction, right? This negative sign means that these guys will cancel out, and then we'll get 5 minus 3. That'll give us a no, not negative. That'll just give us a 2. That gives us 2x. Okay, and so now the next digit drops down. The 6 drops down, and we write plus 6. And then we repeat the process for this value right here, just like we did with the normal division. So we say, what times this first term x is going to give us 2x? 2. Boom. All right. Now we go back through and multiply out. 2 times x is 2x. 2 times 3 is 6. We subtract that from this upper value, and we get a total of 0. Now that we're at 0, we're good. So what's the relationship between these guys? Well, obviously the division, but you'll notice, just like when we're dividing real numbers, there is always a specific relationship. 3 plus 3, or x plus 3 times x plus 2 is equal to x squared plus 5x plus 6. And that's how you check your work with this. So you take your result, you multiply it by your original divisor, and then you make sure that you get the polynomial that was inside this guy, right? Okay. And we're going to learn, don't freak out, because we're going to learn soon what to do if this is not a 0 here. All right, let's try this guy again. So actually, why don't you guys try this on your own? That sounds like fun. It's okay to talk to each other about it too. It's totally fine. Can you see that, Misty? Sorry, I made it smaller so you could see the example too. All right, let's continue. So, for this guy here, same thing as we did on the last example. We're going to say, what can we multiply this first term in our divisor in order to get this first term in our dividend? I think that's the proper way to reference those. Anyway, 2x times what equals 2x squared? X. Cha-ching, throw an X right there, right? Then we go ahead and multiply it out.
I'm thinking, well, that's 1, so 2 times 1. Okay.
So now we multiply each term in our divisor by our number we just came through with. So, and if you choose the wrong number up here, you're going to realize it real quick when you get down to this next line. So 2x times x, well, that is 2x squared. Whoops. And then -1 times x, that is -x. Okay, we're going to put a negative out here, which makes this one a negative and this one a positive. All right, there's 0 here. And then 5x plus x, that is just 6x. The 1 is going to drop down. And then we say, well, what do we multiply 2x by to get 6x? 3. All right, go ahead and multiply that out, and that gives us 6. Whoops. That gives us 6x, and And then negative 1 times 3, well, that's negative 3. We throw our negative sign out here, which changes this to a negative and this to a positive. And we get 4 left over. So this was a bad example to give you guys at first because there's a remainder in this one. We're not sure how to do that yet. So we know that there's a remainder when the degree of this number here is less than the degree of this number here. That's when we know it's time to stop. You know, it's going to be obvious anyway because you're at the end of your polynomial, but you know it's time to stop when the degree is less than the degree of this guy. So how we write this guy out is we write what we got for our answer, and then we write the rest in remainder form. And so we have x plus 3 plus 4 over the divisor, 2x minus 1. Right?
No.
It's so the same way that you would check the other ones, right? Yeah, you would say you would multiply it 2x minus 1. Yeah, you do it like that, and then you would see if it equals your dividend. And so it's the same way. It's just a tougher check, like, you know, which means, of course, you guys will do it still, right? Right? No, there's some of those ones, like especially the multivariate ones with like 10 different terms where I'm not going to check that. I'm just going to assume it's right. Just regret it later. Yeah, with this one, you'd multiply 2x by each and every term, and then you'd multiply 1 by each and every term. Whoops, forgot one. No, forgot that one. All right. So, let's see now. This is a good one. This is a great example. So for this one, just note real quick that there's a jump in degree between terms. This goes from a 3rd degree term to a 0 degree term, and that's going to give us problems with this normal division method. So we're going to rewrite this one. This is now going to be written as x plus 1. We're going to divide it by x cubed plus 0x squared plus 0x plus 1. And so I put those 0 placeholders in for the gap in degree. All right, so once again, in our first place, we're going to put an x squared because that's what we multiply x by to get x cubed. All right, and so now we're going to multiply all our terms in our divisor by our new number that we just threw in here. So we have x times x squared, that is x cubed, just like we wanted. We'll throw a negative on it. 1 times x squared, that is just a single x squared, but it's a negative because it's in our second line here. Okay, so our negative x squared drops down, and then we have plus a 0x that drops down with it. Okay. So now we play the same game, right? What do we have to multiply this first term in the divisor by to get negative x squared?
0.
No. 0 times anything is just 0, right? We don't want it to equal 0. We're looking at this new term right here, right? And so we want to turn this into this first term here. We multiply it by a negative 1. Sorry, a negative x, not negative 1. What am I thinking? Negative x. So negative x times this first term here, x, that's going to give us a negative x squared. I'll write my parentheses and my negative sign out here so I don't forget to change these signs. A positive 1 times this negative x, that's going to give us negative x. All right, and then we're going to distribute this negative in, so these two signs are going to switch. All right, so these guys go away, and we get a solo x down here. I'm totally running out of room. Just a second here. All right. So we dropped our single x down, or we subtracted to get our x. Now we drop our next digit down. What's up?
Why would x to the second minus x to the second? Why would that be 0?
You mean this term right here?
Down. 0x to the second minus x to the second.
Oh, this here.
Yeah.
So it's 0x to the second minus x to the second. That's equal to negative x to the second.
That was right.
Right? Yeah. I see what you mean. Yeah. 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 And so that's, yeah, even though we have this 0x as a placeholder, the term that we're going to be trying to multiply that by is going to be what drops down after we do our first multiplication.
Got it.
So, okay, so on this last step, we see that we have an x plus 1. What do we multiply x by to get x? 1.
1.
When we do our multiplication on that, we have x plus 1, and of course that's a negative, which gives us a 0 as a result. So our final answer is this guy up here. And we can say, now that we know that x plus 1 times x squared minus x plus 1 should equal x cubed plus 1. If it doesn't, we've done something wrong. How's everybody on that division stuff? Not too bad. It's kind of...
Just don't put on the test, you'll be good.
Just take it slow and steady.
All right.